Hey, in this tutorial we're going to look at trigonometric equations and general solutions. So this is by far easier to actually explain by just doing some worked examples. Okay, so our first one is solve root 2 cos of x equals -1, okay, between 0 and 2 pi. Okay, so what we need to do is rearrange our equation to start off with, because what we want is our trig function by itself. Okay, so just this part here, cos of x by itself. So we're going, well, cos of x equals -1 over root 2. Okay, so then what we do is we go, okay, well, what is our basic angle? Okay, so when does cos x equal 1 on root 2? So ignore the negative. All we want to know is our basic angle. When does cos of x equal 1 on root 2? Okay, and that's where we look at our exact values. Okay, and when we look at our exact values, we find that x has to equal pi on 4. Okay, so remember, looking at our exact value tables or our triangles that we looked at in the previous tutorial. Okay, then we go, okay, when is cos of x negative? Okay, so when is cos of x negative? Okay, well, it's negative in the second and third quadrants. Okay, second and third quadrants. Okay, so therefore we say, well, x, okay, equals pi minus theta and pi plus theta. This is our second angle, our second quadrant and our third quadrant. Okay, so it's pi minus our basic angle, which we found to be pi on 4, and pi plus pi on 4. Okay, so we find that is equal to 3 pi on 4 and 5 pi on 4. Okay, so we'll look at our next worked example, okay, which is tan of theta equal to -1. Okay, so again, we go, okay, we've got to find our basic angle. Our basic or reference angle. Okay, so when does tan of theta equal 1? Ignore the negative. Okay, don't care about the negative at all. Okay, so we find that equals 1, okay, when theta equals pi on 4. So again, that's our basic angle. Okay, when is tan negative? Okay, because we have -1. Okay, and tan is negative, okay, in the second and fourth quadrants. Okay, second and fourth quadrants. So now the only thing that's a little bit trickier here is our domain. Okay, because we're actually going from -pi to pi. So the difference is, okay, when we usually look at our unit circle, we go from 0 around to 2 pi. Okay, what we're doing here is going from -pi around to +pi. Okay, so we know that we've got an answer that's down here and an answer that's up here. Okay, the answer up here is fine. Okay, that's just the way we usually do it. So that's going to be theta equals our pi minus pi on 4. Okay, that's our one there. Okay, no dramas at all. Okay, and now our other one, okay, is down here, and we go, well, we need to go, what are we going to do here? Okay, because we've got to come from around here, okay, or measured in the negative direction. Okay, so for that one, okay, what we're going to be is our 0 this time, take our pi on 4. So it'll actually just be take pi on 4. Okay, which is just negative pi on 4. So theta is going to equal our 3 pi on 4 and negative pi on 4. Okay, because we've got to measure it in a different way. Okay, so we'll keep going. So they're going to get a little bit harder. Okay, so for this one, okay, what we need to do is we need to, again, get this sign by itself. We can go sine of 2x equals positive a half. Okay, we go, well, the problem that we've got here is our 2, which we'll get to in a minute. Okay, but what we do is we go, okay, find basic angle. Find our basic angle. So when does sine actually equal a half? Okay, and sine equals a half at pi on 6. Okay, now what we do, okay, is multiply the domain by 2. Okay, and we're multiplying the domain by 2, okay, because of our 2 here, sorry, because our 2 here. So that means our domain is from 0 to 4 pi. Okay, and they'll come into play in a minute. Okay, so now we go, when is sine positive? Okay, so sine is positive in the first and second quadrants. Okay, so that means then that we've got 2x, okay, because it's not just x this time, it's 2x. Okay, in the first quadrant, well, it's simply going to be pi on 6. In the second quadrant, it's going to be pi minus pi on 6. Okay, so we're going to say, well, we've got 2x equals pi on 6, okay, and 5 pi on 6. Okay, however, we multiplied our domain by 2, so we've got to go up to 4 pi. All we've done so far is found our solutions in one rotation around the unit circle. So we've got to go another rotation around. But what's good about that is all we've got to do is add 2 pi to these two solutions. So it's pi on 6 plus 2 pi. It's also 5 pi on 6 plus 2 pi. So then we have 2x equals pi on 6, 5 pi on 6. Okay, this would be 12 pi on 6. Okay, so that's going to become 13 pi on 6. Okay, and again this will be 12 pi on 6, so it's going to become 17 pi on 6. Okay, and we're almost there. What we do now, okay, is divide by our 2, okay, which is simply timesing our denominators by 2, so it's pi on 12, 5 pi on 12, and 13 pi on 12, 17 pi on 12. Okay, now you'll notice they're all back within our original domain of 0 to 2 pi. Okay, so for these ones, the idea is, okay, that we need to multiply our domain by whatever the coefficient is there, okay, and then find all the solutions that fit into that domain. On an exam in a stack, you're not going to get anything higher than a 3, because basically every time, whatever that number is there, you're generally speaking going to have double that number of solutions. Okay, assuming that the domain is nice and simple and not a bit of an odd one. Okay, so we'll look at this worked example here. Okay, so again, what we need to do is get just the cos part by itself. So you say, well, cos of 2x minus pi equals 1 over 2. Okay, and we're still in that same original domain. Okay, so find basic angle. Okay, so when does cos actually equal a half? So the basic angle is pi on 3. Okay, we're going to still need to multiply our domain. Because we still have this coefficient of 2 there. We'll get to what we do with the pi in a little bit. That makes it negative 2 pi less than equal to x less than or equal to 2 pi. Okay, cos is positive in the first and fourth quadrants. Okay, first and fourth quadrants are where we're talking about. Okay, so then we go, well, our 2x minus pi, okay, it's going to give us a solution in the first quadrant, which is pi on 3. That's handy. Okay, then we need to think, okay, well, let's think about where we actually are at. So we've got a solution up here and a solution down there. Okay, so just done that solution there, because the problem is this funny domain going backwards. So we actually need to go, well, here's this one, okay, going this way. Okay, to get to this one going this way, it's just going to be negative pi on 3. Okay, and then basically we just need to keep going then and go, well, we've got to then do another lap around basically. Okay, so sorry, just double checking something here. Oh, sorry, there's one thing that I forgot to do on this one. And it's because there's pi here. Okay, because we're taking pi away there. Okay, what works out well is to then actually, in our domain here, take away pi from each of them as well. Sorry about that, I forgot that step. Okay, so when we do that, we find our domain is minus 3 pi. Okay. The reason why we do that is it just makes it a little bit easier, because what would happen if we didn't is we'd need to add pi to these ones, okay, and we would actually push out some of our higher values by adding our pi. They'd be outside this domain, and there would have been a solution that was less than negative pi that wasn't brought up when we added our pi there, because we didn't have it in our solutions here. Generally speaking, it's not too big of a deal, because often this might be like plus pi, or like take pi on 4 or take pi on 6, and you don't have those issues. But with one as big as it is, okay, we really need to make sure that we're doing something like this just to make sure we don't miss solutions. It's not too bad if you don't do it like this and that you double check and make sure, okay, but just to be consistent with what the textbook does, I just want to do it this way as well. Okay, so basically what we've done then is, so here's our positive pi, okay, so we're only going to get one solution there. Okay, we've come around, here's negative pi, okay, so we've got that solution. We need to go another negative pi and get this solution here. Okay, so what that means is we're going to have to go then, I have to fit down here, is we're going to go negative 2 pi plus our pi on 3, that'll give us this one. Okay, and then to get this one, we also need to do negative 2 pi minus pi on 3. Okay, so now we've got 2x minus pi. I'll just write it out a little bit better. Okay, so we've got our 4 solutions. Okay, what we can do now is add on pi to all of them. So we've got 2x equals pi on 3 plus pi, negative pi on 3 plus pi, negative 2 pi plus pi on 3 plus pi, and negative 2 pi take pi on 3 plus pi. Okay, and that looks a little bit messy because we hadn't simplified those ones. Okay, but we'll simplify them now. So this one's going to become 4 pi on 3. Next one will be 2 pi on 3. We've got negative 2 pi on 3 and negative 4 pi. So negative 4 pi on 3. Okay, then we've got to divide by 2. Okay, and again that's just multiplying the denominators by 2. So just remembering, because we had a large value here for a translation, then what we did was we took away our pi from our terminals on our domain to make sure we didn't miss any solutions. So we would have missed some solutions, okay, if we didn't do that. Okay, and we would have probably included ones that we didn't want. Okay, so you just got to be really careful when you do some of these ones that have a translation in them as well, that you don't miss out on a solution either previously or after what your domain was when you were working with it. Okay, so we'll keep moving. Okay, got a couple more that we need to do. Okay, because there's other types of nifty things we can do with these. Okay, so what we're going to do, okay, is for this one we've got sine of 2x equals cos of 2x. Okay, what we're going to do is divide everything by cos. That means we've got sine of 2x on cos of 2x equaling cos of 2x over cos of 2x. Very, very, very typical exam type question, because sine over cos becomes tan 2x and cos over cos becomes 1. Okay, so once we get that part, then we can go okay, because we go okay, basic angle. Okay, if we look at our exact values, okay, we find our basic angle is pi on 4. Okay, we find that tan is positive in the first and the third quadrants. Okay, we need to multiply out our domain, so our domain becomes 0 is less than x is less than 4 pi because we have 2 in there. Okay, so now we can say, well, our 2x, okay, is going to equal our basic angle because we're positive in the first. Okay, in the third, well, it's pi plus pi on 4. Okay, and we're going to go around again, so we're going to add 2 pi to these to get to our full domain. So you say pi on 4 plus 2 pi, and then say pi plus pi on 4 plus 2 pi. Okay, so then we say, well, 2x is equal to pi on 4, 5 pi on 4, 9 pi on 4, and 13 pi on 4. And then we can divide by our 2 again to get pi on 8, 5 pi on 8, 9 pi on 8, and 13 pi on 8. Okay, we'll keep moving on to our next one here. Okay, again, this one can look a bit daunting, but there's a really good technique, and again, whether it's in the form of a trig question or it could be a form of an exponential type question, there's going to be, I'd almost guarantee, a question like this on the exam. Okay, so we've got 2 sine squared theta plus 3 sine theta take 2 equals 0. Okay, first thing we need to do for a question like this is do something like let A equal sine theta. Because when we rewrite the equation then we get 2a squared plus 3a take 2 equaling 0. And look at that, we have a nice quadratic now, okay, that we can factorise. So when we factorise that, we get 2a take 1, okay, and a plus 2 equaling 0. Okay, you can check that yourself if you don't believe me. Okay, null factor law means that our 2a take 1 equals 0 and our a plus 2 equals 0. Therefore, okay, a equals a half or a equals -2. Okay, so what we're saying then, well, is that sine equals a half or sine equals -2. Okay, now we need to think though, like, can we actually use -2 though? Okay, and the answer is no, there is no solution, okay, for sine equaling -2. Look, a lot of the times I'd say it's 50-50 whether they make one where you can't use it or whether they actually do it where you can use both. So we can ignore that one completely and now just solve sine of theta equaling a half in this domain. So basic angle, okay, when is sine equal to a half, and that's pi on 6. Positive in the first and the second. So theta equals pi on 6 and pi minus pi on 6. So theta is going to equal pi on 6 or 5 pi on 6. Okay. Right. One more that's a little bit different here. Okay. So we've got cos squared of 2 alpha take 1 equals 0. Okay, so for this one, okay, we want to multiply our domain like we usually would. Or actually, we might rearrange a little bit first. So we've got cos squared of 2 alpha equals 1. Okay, multiply our domain by 2, so we get negative 2 pi to alpha to 2 pi. Okay, so looking at that now, okay, and we need to go, okay, well, hang on a second, what are we going to do here? Okay, the answer is, again, we let cos of 2 alpha equaling a, so that means we've got a squared equals 1, so that a equals 1 or negative 1. Right, 1 or negative 1. So now we're going to solve cos of 2 alpha equals 1 or cos of 2 alpha equals negative 1. Okay, is what we need to do. Okay, so if we start off with our first one here, equaling 1. Okay, so we need to think, when does cos equal 1? Okay, so we've got 2 alpha. Okay, so for this, okay, we find, and we did look at it previously, okay, that at 2 pi and 0, okay, is when cos equals 1. Okay, because we're including both our n terminals, okay, then we need to be saying that it happens at negative 2 pi, it happens again at 0, it happens at 2 pi. So we're actually getting an extra solution here. Okay, so that means that alpha equals negative pi, 0 or pi. Okay, and when we look at this one, with negative 1, okay, well that happens, okay, at pi and negative pi. Okay, is when we equal negative 1. So therefore alpha equals pi on 2 and negative pi on 2. Okay, so we had some of these ones where we equaled 1. Okay, if you look back at the exact value table, they give us like our whole numbers of pi. Okay, so all up then, alpha can equal negative pi on 2, 0, pi on 2, and pi. Okay, so we're getting there. Just going to look at some general solutions. So this is our last page. So our general solutions is basically when we're not given a domain. Okay, and remembering that all our solutions are basically multiples of 2 pi more or less. Like we can add multiples of 2 pi to them. Okay, so our general solutions, sine's probably the most complicated one. So we say if sine of theta equals a, then theta equals 2n pi, okay, plus the inverse sine of a. So just think, okay, inverse sine of a, okay, is our basic angle. That's how we get our basic angle. So that's not too big of a deal. Okay, and this one's our solution in the first quadrant. So if we add 2 pi to our first quadrant, okay, then we'll get back to the same solution. If we add another lot of 2 pi, okay, we'll get back again, or another lot of 2 pi. Okay, and that's what the n does, is how many lots of 2 pi we're going to add, okay, to our answer in the first quadrant, okay, to get more solutions. Okay, this one over here, okay, is to take care of our solution in the second quadrant. Okay, and it's 2n plus 1 pi take our basic angle. So because remember, it's pi minus our basic angle, or it would be 3 pi minus our basic angle, or 5 pi minus our basic angle, or 7 pi minus our basic angle. So we don't want to add 2 pi, or just standard 2 pi. Okay, we want to make sure that we're 3, 5, 7, that sort of thing. Okay, so that we're our odd numbers. So we get that by doing 2n plus 1 lots of pi onto this solution. Okay, for cos, much easier. That's 2n pi plus or minus the inverse cos. Okay, so that one's a lot nicer. It doesn't matter which solution we use. Okay, we just add 2 pi to them. Okay, for tan, our solutions actually repeat themselves every n pi, so every pi. So really all we're going to do is add pi to our answers and we keep getting the same thing. Okay, so we're going to look at finding the general solution of the equation 2 cos of 2 theta equals root 2, and hence find the solutions for theta between minus pi and pi. Okay, so last work example that we're going to do. Okay, so to start us off, okay, we need to just fix this up a little bit and say, well, we've got cos of 2 theta equaling root 2 on 2. Okay, our basic angle. Okay, so when does cos actually equal root 2 on 2? Well, that's going to be at pi on 4. Okay. Okay, we need to multiply our domain out. Sorry, no we don't. Sorry, we don't need to multiply our domain out for this one. Okay, just with the way it works with our general solutions. Okay, so our cos is positive in the first and the fourth quadrants. Okay, and then we look at our solution up here. Okay, so basically we say 2 theta is equal to 2n pi plus or minus, okay, our inverse cos of root 2 on 2. Now, because this is here, okay, it's root 2 on 2, well we know that is our pi on 4. Okay, we know that's our pi on 4. Okay, so then we can simplify this. Okay, so we put in our pi on 4. Sorry, let me just double check what's happening here. Oh yeah, we're just simplifying a little bit. So we can say 2 theta equals 8n pi on 4 plus or minus pi on 4. We're just doing this so we can make it look a little bit nicer. Okay. So then we can say, well, we've got 2 theta equals 8n pi, oops, sorry, 8n pi plus pi on 4, or we've got 8n pi minus pi on 4. Okay, so just so we can write it a little bit nicer. Okay, and we can make that still a little bit better. We can say, well, we've got 2 theta equals 8n plus 1 pi on 4, or 8n take 1 times pi on 4. Okay, so therefore our theta equals 8n plus 1 pi on 8 and 8n take 1 pi on 8. Okay, so getting there. Okay, so we need to find our solutions now for in here. Okay, so we need to substitute appropriate values of n to achieve our solutions in our domain. Okay, so if we were to put in, say, -1 into here, okay, if we were to put -1 in here, okay, it would be, well, we'd have -8 plus 1, okay, which would give us -7 on 8, so we get -7 on 8 pi. Okay, if we put into here, well, we get -9 pi on 8. Now that's outside our domain, so we don't want that. Okay, we also need to think, well, what happens if we make, say, n 0? Okay, well, this would make this one pi on 8, and this one would be, oops, sorry, pi on 8, okay, and this one would be -pi on 8. Okay, still all inside our domain. Okay, and if we put in 1, okay, well, this one would become 9 pi on 8 and would be no good, but this one would become 7 pi on 8, which is okay. Okay, and that would be all our solutions for theta. Now, so it's a bit of trial and error with just picking values. Okay, you might have picked 2, negative 2, you would have found that you're miles out the domain as well. And you just need to go, okay, make sure that you haven't skipped any numbers, because remember, n's whole numbers here. Okay, so n are our integers. Okay, so we need to make sure that we're trying a range of different ones. Okay, so that should be enough to get you through the questions on this section, hopefully.